All right, looks like we got Trig lecture 8:30, 8:31, and 9:1. So we'll have 3 days of doing this stuff, and then on 9:2, that'll be next Thursday, or on this Thursday, we'll review everything we covered from the beginning of the semester up to this point, and we'll have a test on Friday, 9/3. Okay, that's the plan. Today, the objective is going to be the student will use trigonometric ratios. It's just trig ratios, opposite over hypotenuse, that sort of stuff. Trigonometric ratios, another word for fraction. Trigonometric ratios to find the length of an indicated side of a given right triangle. So we're going to be given a right triangle, and we're going to be asked to find one of the sides. We just got to figure out which side we're looking for and use our trig ratio to find its length. Here's how that works. Let's take a look at the first example. So let's find the length of the indicated side round to the nearest tenth. Okay. So I look at it, here's my triangle that I'm given, and I want to find the indicated side. The indicated side is the one that has the variable for its length. I don't know this side. That's the one they're asking me to find. They're giving me this side, in this case, and they're giving me the measure of this angle right here. So I'm looking at that and I'm thinking to myself, well, which of my trig functions, I like to start with sine, cosine, and tangent, the three basic trig functions, and ask myself which one of those involves an angle and its adjacent side and the hypotenuse. And I think about that for a second and say, well, that's the cosine. So I'm going to make a statement. I'm going to say that the cosine of 25.8 degrees is adjacent over hypotenuse. And now I've got a nice little equation that I can solve pretty easily. If I solve this thing for x, back in Algebra 1 and pre-algebra, we learned that we get rid of a divided by 8 simply by multiplying both sides of the equation by 8. So that's what I'm going to do. I'm going to multiply both sides of this by 8. That will cancel, leaving x by itself, which is what I'm looking for. X is the length of this side. And when I rewrite this thing, I'll have 8 cosine 25.8 degrees is equal to x. Now all I have to do is take my handy dandy calculator and figure out what 8 cosine 25.8 degrees is. So here we go. I'll take my calculator, say 8 times the cosine of 25.8 and hit equals. And I get 7.2. I'm going to put units because I don't know what my unit of measure is. This length could be in miles, or it could be in centimeters, or it could be in light years. I don't know what it is. They didn't tell me, so I'm just going to put units. It probably won't be that way on the multiple choice. I can take a look real quick. No, the units aren't going to be listed, but this is going to be 7.2 units of some sort. That will be the length of that. If this is 8, and this is 25.8, and this is a right triangle, this will have to be very, very, very close to 7.2 units. All right, and let's see if I got that one right. I'll just look at this and do a look and see if I got it right. I got it right, yay. Okay, let's take a look at another one. Here I've got another right triangle. And my angle is 56 degrees. My adjacent and my hypotenuse, again, that's the cosine function. Coincidence. So I'm going to say, well, the cosine of 56 degrees is equal to adjacent over hypotenuse. In this case, my variable is in the denominator, and we don't want that. We don't want the variable in the denominator. I'm going to show you how to get it out of the denominator, and then I'll show you a shortcut, okay? So I'll do this one in two ways. One will explain why the other one works. To do this algebraically, we could say, well, we can multiply both sides by x, and this will cancel out real quick and give me x times the cosine of 56 degrees is equal to 8. And then I say, well, I want x by itself, so now I'm going to divide both sides by the cosine of 56 degrees. And that will yield x, these cancel, equals 8 divided by the cosine of 56. And then I could take my calculator and go 8 divided by cosine 56, enter, and it would give me a value that I would then round to the nearest tenth because that's what I'm told to. Okay, you see how this worked algebraically. I'm going to show you the shortcut now, as I said I would. Here's the quick way of doing that. If we have cosine 56 is equal to 8 over x, if our variable's in the denominator and we have just a statement like this where there's no addition or subtraction going on, if we want x, this thing solved for x, we can just switch the places of these two. We can just go, whoop. And this is why we can do that. Here the original equation was cosine 56 is equal to 8 over x, just like that. If we switch these two, we'll get this. Okay. So you don't have to go through all this algebra all the time. You can just switch these two and then perform the operation. So with that in mind, let's just put this in our calculator and see what we get. X is equal to 8 divided by the cosine of 56. X, 8 divided by cosine of 56. 8 divided by the cosine of 56 equals 14.3. I'm asked to round it to the nearest tenth. So I would say x is equal to 14.3 units. Be inches or miles or whatever. We don't know what the unit is, but whatever it is, there will be 14.3 of them approximately. And now I'll check to see if I've gotten it correct. Yay, 14.3. All right, so let's take a look at another one. Here's another triangle. Hey, it's got cosine again. How strange. I should have looked at that a little more closely. I've had the computer print off some examples, but that's just, you just determine what trig function you're going to use based on what you're given. I look at this one and say, well, here's an angle that I know. I'm going to say that the cosine of 24 is adjacent over hypotenuse. And I'm choosing cosine again because I'm given adjacent and hypotenuse, so I'm looking for the adjacent side. So here we go. The cosine of 24 degrees is equal to x over 15. Well, here the x is in the top of the fraction already, so I don't have to do that switcheroo thing. We do that when the x is in the bottom of the fraction. All I have to do here is just undo, so to speak, this divided by 15. And in algebra, we were taught we do that by multiplying by 15. If I multiply this side by 15, making x all by itself, I have to multiply this side by 15 just to stay in balance. I rewrite my equation. 15 cosine 24 degrees is equal to x is all that's remaining on this side. And so I can say x is equal to 15 times cosine 24, whatever that is. About 13.7 units. And I want to make one little correction that I've done in all three of these so far. I said x is equal to, this is an approximation. So we can use an approximation, we should use an approximation symbol. There are two symbols that we use for approximation. You can put a dot over an equal sign, or you can use a squiggly equal sign. Both of them mean approximately equal to. So I'm going to go fix these two. Where'd I put my answer? There it is. That's an approximation. And that's an approximation because I rounded to the nearest tenth. Okay. So where am I? X is approximately equal to 13.7 units, and I think that's correct. Let me look. Yes, yay. Right, let's take a look at one more. I hope it isn't cosine. If it is, I want to be sad. It is. How about that? Well, no, it isn't. That one's the sine function. Yay. I'm looking at this and from this perspective. Now, don't forget, if you know this angle, you automatically know the other acute angle. We can just subtract this from 90 and get this angle if we wanted to. But I'm just going to use this. I'm going to say that this involves opposite over hypotenuse. That would be the sine function in this case. So I'm going to say, well, I can see that the sine of 68.9 degrees is equal to opposite over hypotenuse. Now here I've got a situation where my x, my variable, is in the denominator, and I don't have any addition or subtraction going on. So if that's the case, I can just go boop, switch those two. X is equal to 7 over the sine of 68.9 degrees. And we illustrated above why that works. Now I can make my approximation. I'll say x. This is exactly the length of x. 7 divided by the sine of 68.9 degrees. Now we're going to approximate it. We're going to round it to the nearest tenth because that's what we were asked to do. So I'll say 7 divided by the sine of 68.9 equals about 7.5 units. And those units could be, again, centimeters or kilometers, miles, light years. Let's see if I got that right. 7.5, yay. They're going to be multiple choice, so you just find the right one. Again, if the variable's in your denominator, when you set up your trig ratio, you can just switch these two for reasons we discussed above. And that is how we use trigonometric ratios to find the length of an indicated side in a given right triangle. We just determine which trig function we want to use, set up an equation, isolate the variable, and use our calculator to evaluate our expression, our trig expression. So there we are. You can do this.